Welcome to the AWS Greengrass Technical Deep Dive. I'm Craig Williams, a Partner Solutions Architect and IoT Specialist with AWS. In this session, we're going to do a quick recap of AWS IoT so that we can level set and make sure that everybody follows along with the talk. We're then going to look at why you need Greengrass, what it is, and why we decided to build it. We're going to do a Greengrass deep dive. This is a very technical deep dive looking at all the different components and helping you set up a Greengrass group. And then we're going to have a short demo actually showing a working Greengrass group. AWS IoT is a fully managed cloud platform that lets us connect devices easily and securely. It allows us to connect many devices. We can have one device, we could have 100,000 devices, or we could have tens of millions of devices. And AWS IoT is designed to make that really easy for us to do. Unlike traditional architecture where I would normally have to consider load balancers and auto-scaling groups, the kind of things you think about when you're working with EC2, those are all solved for you. And the IoT platform is designed to just be seamless in terms of how it scales. And so as you design your IoT solutions, we've taken all that architecture into account for you, and you easily connect hundreds of thousands of devices, and we'll scale the front end, and you then figure out the back end architecture and how you want to actually consume your data. So let's do a quick recap of the IoT platform. It's important to make sure you understand the key components on this platform, as these are the features that we've actually extended into AWS Greengrass. Everything in AWS IoT centers around our device gateway. The device gateway is a very simple pub/sub broker. Everything that you're doing with our device gateway is publishing to topics and subscribing to topics to then receive data. And everything you do revolves around that concept. And so as we talk today and we look at state and shadows and we look at processing at the edge, if you get confused, just remind yourself that we are publishing data to topics and we are subscribing to topics to get that data back. So connecting to our device gateway requires us to have a certificate. We take security very seriously, and we want every device that connects to the device gateway to have its own certificate. You can generate certificates yourself. We support just-in-time registration of certificates. We can generate certificates for you. You can have millions of certificates. You can have a small number of certificates. There's no actual cost within AWS IoT for certificate creation and storage. The only cost in IoT itself is around actual messages, right? So we encourage you, even in development, if you need a lot of certificates, to go ahead and create those. A couple of exceptions for certificates in terms of one per device is just when we look at gateway devices. And even when we start to look at things like Greengrass and hubs and devices at the edge, some of those devices, it's perfectly fine for them to have a single certificate. But in general, a certificate is something that is required. We do not support username and password authentication, which is in the MQTT spec, but we don't consider that secure enough. Along with that, we have a security policy that determines what you can do when you've actually connected to the device gateway. And we also require your devices to actually be in our device registry. Once you have all of that, you can then communicate to the device gateway. What about protocols? We support MQTT, HTTPS, and WebSocket connections. Now, generally speaking, IoT devices are constrained devices. We want you to be using MQTT. It is a constrained protocol. Out of all the constrained protocols, it has the smallest bandwidth footprint. And so you don't want a lot of overhead, a lot of memory usage on constrained devices. We really want you to use MQTT. And then for any control devices, think about iPads or mobile phones that people might be using, those also support MQTT. And so it's a great protocol for all the communication that we're going to have with our device gateway. And of course, it is the primary supported protocol within Greengrass itself. Outside of that, if you're going to use a WebSocket connection, that is something that you would traditionally do from a browser. And so you can have that two-way communication from your browser, controlling IoT devices, which of course are still communicating with MQTT back to the device gateway. Next, we have our rules engine. And so sending data is very easy. But what are we going to do with this data when we actually get it? The rules engine is where we bring a lot of value. This is how we determine what downstream services we want to send our data to. We could send it to S3, we could send it to DynamoDB or Lambda or Kinesis. We can send our data in multiple directions at the same time. Every rule can act on the same incoming message. So I can have multiple rules firing in concurrent connections. I can have multiple actions per rule actually executing at the same time as well. And so this lets me filter off some of my data. Maybe I want to send a copy of all my data through Kinesis Firehose to Redshift so that my data scientists can process it later. And the rules engine is where I'm going to put all this functionality. And it's also a great compute resource that's provided by the platform. There's no additional billing for it. And it allows me to filter my data. I can I can enrich my data. I can add timestamps to it, for example. And I can also query down inside of my data sets. I can look for values within collections that are coming inside of the JSON payloads, and then make decisions about where I want to send that data or how much of that data I even want to send to a downstream system. Next, we have our device shadow. The device shadow is the most critical component to understand within AWS IoT, and the same is true for Greengrass, because the shadow is how we do all our command and control operations, and definitely is a piece of functionality that we have built into Greengrass. How does the shadow work? Well, the shadow is a block of state information. It is 4K of JSON data about your device, and what goes inside the shadow is completely up to you. Typically, the kind of things you put in there are the operational state of a device. So a quick example is going to be, let's say I have a smart light bulb, and I have a phone that wants to control that light bulb. Well, the phone can never talk directly to the light bulb. Network-wise, that is not an option. It's never an option. And so the phone will query the device gateway so that it can get a copy of the shadow, and it will see that the light bulb's current state is off, and it can issue a change to the shadow to change the state to on. The light bulb, in turn, is watching its shadow and sees the state change and can then make the change and report the shadow back to the device gateway. And the device gateway is managing the shadow. Okay, so everything is communicating with the device gateway, and it's actually doing it just on a set of topics. And so again, it is pub/sub. There's no black box scenario here. We are publishing to a set of shadow topics. We are subscribing to those topics to fetch our data. And so the shadow gives us a controlled way of knowing the state of a device and making 100% sure that when we change the state of a device, that change happened in a controlled fashion. It allows us to essentially communicate with devices that are offline, because when they come back online, they will query their shadow, they will see the change, and then they can act on that change. The shadow also solves unordered messaging problems for us, in that if I make rapid changes to the state of a device and I send lots of on-off messages, those messages might arrive out of sequence. And so they might arrive off, 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 on. And to avoid that, our shadows are actually versioned. And so you're only going to obey the latest version of your shadow before you actually make a control change. So the shadow is very important. We can use it for things like firmware updates, because we can look at the current firmware of a device through its shadow. We can tell the device, hey, on this date and time, go to this location where you can fetch new firmware, and then the device can make an update. And then we can also track the updating of that device through its shadow. So one downstream service I'd like to touch on here quickly is Lambda. Lambda is our event-driven compute service. It allows us to execute small blocks of code in response to events, and for IoT, it is absolutely an ideal service. As I have millions of messages flowing around my IoT solution, I can have Lambda processing all that data and sending alerts or doing analytics or sending control messages back to my devices. And so keep that in mind, because when we look at Greengrass, you'll see how we've extended Lambda to the edge as well. Why Greengrass? Why did we decide to build AWS Greengrass? Our customers have been building IoT solutions for many years in the field already, and we're all coming across similar problems. The first one is the law of physics, which has to do with latency and connectivity to the cloud. We don't know that we'll always have a connection to the cloud. We need a way to be able to process information and act on events when we are actually disconnected. So that was something that was a goal of Greengrass. Along with that, we needed to be able to have low latency processing. So if you think of an industrial environment, I don't want 100 millisecond response time because I need to go to the cloud, execute Lambda there, and come back. So by executing Lambda within Greengrass, I can have a quarter of a millisecond response times. And those response times are going to be guaranteed every single time I get a message in. Because, again, there's no latency because I'm not going across a connection to the cloud. Next was the law of economics. We don't want you to have to send all your data to the cloud because you're paying for the bandwidth to get to the cloud. Along with that, you're paying for every single one of the IoT messages that is flowing up to AWS IoT. And so we want a way for you to process your data at the edge. And because it's running on your hardware, there's no cost for doing that outside of the cost of running your hardware. And so it's far more economical to actually process your data at the edge on something like Greengrass before you decide to send any of it to the cloud. And next is the law of the land. And this is data security and privacy. You may have environments, especially sensitive environments, maybe it's a medical environment, where you want to move around information, maybe it's patient information, and you want to be able to process it and act on it, but of course you never want to send it to the cloud. Or you want to anonymize your data before it actually leaves the particular site. And so that's something Greengrass can do, right? It can run completely offline, low latency, and completely private environments. And when needed, and if you need it, you can then send your data up to AWS. So what is AWS Greengrass? Greengrass is an extension of AWS IoT. We have extended it to a software package that runs on your hardware, and we have brought down 4 key components from AWS. We have brought down Lambda so that you can have compute operations at the edge on your hardware. We have brought down the broker, so devices at the edge can connect to the broker. They do not require connection to the cloud anymore. We've brought down the same security model, and that devices need to have certificates to connect to Greengrass. And then we've brought down the critical shadow functionality, which we need for command and control operations and securely and safely managing the state of our devices. The Greengrass Core is the heart of Greengrass. And so when we talk about the core, we are talking about the package, the runtime environment that actually runs everything that is Greengrass. And so the core runs Lambda execution. It manages the container environment. It manages the broker and messaging, the security, of course, the device shadows. And then the core itself manages a connection back to AWS IoT and to the cloud, and manages any data flow that might be going from the cloud to the core and back again. What kind of requirements does the core itself actually have? Off-the-shelf kind of hardware, right? We're looking at things like a Raspberry Pi. It's not designed to run on microcontrollers. We are bringing a lot more functionality and power to what you're trying to do at the edge. And so it really isn't suitable for a microcontroller, but it is suitable for devices like Raspberry Pi. It's also capable, of course, of running on any kind of hardware you want. So if you want a large 16-core or 16 CPU, 32 gig beast of a server, go ahead, right? That's something that you can run it on. We have RAM requirements there of 128 megs. Hardware architecture here is important to understand. We currently support 2 types of ARM, which are basically ARM v7 and v8, and x86 hardware architecture. And that's important because the core itself is a binary package. It is pre-compiled and is not something that you can actually get the source for or compile yourself. And next, it has to run on Linux. And we'll get into some more details and specifics around what your Linux environment has to have. And we have a lot of that in our documentation on site on the Greengrass website as well for you to take a look at. So the sky really is the limit. If you run this on a Raspberry Pi, of course, you'll have limits on what your Lambdas can do just because there's a limited amount of CPU capacity. If you want to run this on a large server, then Greengrass will take advantage of that. The container engine, of course, can scale up and consume the hardware that you actually give it. We have many SDKs. For IoT, of course, we have our IoT device SDK. This is an embedded SDK that is used to talk to AWS IoT, to that device gateway that we were looking at earlier. It is important to note that none of our services actually require an SDK. And so for you to talk to AWS IoT, you can actually do that natively in most languages using existing MQTT libraries. This is also true for Greengrass. The broker is the same in that I can use Python PAHO libraries and I can talk directly to the Greengrass Core. I can use the existing embedded SDK that I use with the cloud to actually talk to the core, which means we've got coverage for all the major languages. And then just note that we actually have a specialized Greengrass Aware SDK. It is available on our website with the other embedded SDK. What you need to understand with this Greengrass SDK is currently it's only available in C++, but it gives you the functionality of having a device awareness. And so when your device comes online the very first time, it can self-provision. It can find the Greengrass core that it needs to be talking to. It can get a set of certificates. It can find its endpoints and the port that it needs to actually connect to the core automatically. And so we've been able to automate that whole process. That's available in that SDK, and we will have more support for other languages in that in the future. Next, let's talk about a very important concept, which is the Greengrass Group. We need a way at the edge to define all the different components. We've got cores, we've got devices, we've got security. How do we group all of this together so that it can securely communicate with each other, right? And we can share configuration data. We do this using what is called a Greengrass Group. And if you go into our IoT console, you'll notice that the only thing you can do with Greengrass when you start is actually create a Greengrass Group. And within the group, we have our Greengrass Core. You can have one core within a group. We have multiple devices that belong to that group. We have login information. And so where our core is actually logging data is important, so we can log locally. We can also log to the cloud. And so those login environments and definitions are attached to the Greengrass Group. We then have a list of Lambda functions. This is how we control which Lambda functions go from AWS down to the Greengrass Core. And then we have what is called a subscription list. And the best way to think of this is as a routing table. And the subscription list says that data from a particular source to a target on a particular topic is allowed to take place. And we require an explicit route for every single data action that could take place. And so if you have a device talking to a Lambda function on the core, you would define that as a subscription list. And you could say, this light bulb talking to this particular version of a Lambda function on my core on a particular topic is allowed to take place. And then when the Lambda function wants to talk back to the light bulb, you would define that as well. And the Lambda function becomes the source and the light bulb becomes the target, and then you specify the topic that they can talk to each other on. And then if you want to communicate with the cloud, you will have a source and a target that are defined as the cloud. And then you just use a regular topic name and data to that topic. If the target, for example, is the cloud, the Greengrass Core will then handle routing all that information up to the cloud. And so the Greengrass Core manages these long-lived connections. It is sitting there. It will actually buffer any data that's due to go to the cloud in the event that the connection is not available. And when the connection is available, it will stream that data up to the cloud. Just keep in mind that that is a one-way operation. AWS IoT itself still will not buffer data for you. It will not keep anything. It will not retransmit anything back down to the Greengrass Core, to the edge devices. So let's talk about local Lambdas next. Lambda is one of the most powerful features of the Greengrass Core because it can be used outside of just your IoT solutions. This is Lambda on your hardware, running in a disconnected fashion, yet it has the same developer benefits of working in the cloud, in that I can write code centrally. I can write code in my browser, and with one click from the browser, I can deploy that code to physical devices located anywhere in the world. And those Lambda functions will scale the same way. If I have thousands of events at the edge, those Lambda functions will scale to process all of that information at the edge as well. And then I can debug information and logs from those Lambda functions. And anything logged in those Lambda functions can be streamed automatically up to CloudWatch and arrive within seconds. And so this is awesome for developers. No longer do you have to think about, well, how do I deploy code at the edge? How do I keep it up to date? How do I debug it? How do I scale my code at the edge? Okay, that is something that is handled for you because, of course, Lambda operates on a container basis and will scale to meet the load demands. Currently, we support Python 2.7. So your Lambda functions do need to be written in Python. You can package those up, deploy them to the cloud, and then decide when they get deployed down to your actual groups. How do you actually invoke a Lambda function? As I said earlier, that is the job of the routing table. So when messages arrive on certain topics, if there's a route that says these should go to a Lambda function, then that payload will be delivered to the actual Lambda function. Now, these Lambda functions are neat in that on the cloud Lambda, you have a 5-minute execution limit. That is not something that you have at the edge, which is great. I can run Lambda functions for hours. I could have pinned Lambda functions that run permanently. And so as soon as the core starts, the core will actually activate those Lambda functions and keep them running. And then along with this, you can bundle any Python modules with your Lambda function. If you want to do machine learning or make predictions at the edge, that can all be bundled inside of your Lambda functions. Your Lambda functions can also reach out to the host. Now, you do have the same container restrictions and container security that you have in the cloud, but just like the cloud, your Lambdas can reach out to third-party services. You can talk to a Redis cache on the host. You can talk to a MySQL database. As long as you bundle up whatever you need inside that Lambda function, it'll be deployed then to the core and can make use of those local resources. So what am I going to do with Lambda, right? Obviously, command and control, can make decisions. I can work in a completely offline operation. I can filter data and aggregate data. When I see a connection back to the cloud, I can then, if I wanted, I could compress data. I could send bulk amounts of data up maybe once an hour. And of course, I can do some amount of machine learning. So the idea here is that I will learn in the cloud from large amounts of data, and then I will send down models that allow me to do predictions directly off of the core. Our shadows work the same way. Our shadows are also local by default only, which means we don't want you paying for the bandwidth and the message cost of keeping shadows up to date, and so shadows will remain local. But if you want them in the cloud, you can just flip a flag on the Greengrass device and indicate that you want the shadow synchronized to the cloud, and it'll automatically get synchronized then up to the cloud. But again, it's a powerful feature. We still want this for command and control type operations. Right? We want to know the state of devices, even though we're completely at the edge. This is where I might also keep some of my configuration data for certain models for my machine learning modules that are inside of my Lambda functions. In terms of messaging, we have the same broker. So we have an MQTT broker. Your code and your clients connecting to this broker do not know anything different any difference between this and the cloud broker. We have the same security model, and as long as they have valid certificates and they have the certificate of the core so that they can identify the core, then they can connect to the core and publish data. In terms of security, as I said earlier, we have the same security model, right? We want everything to have its own certificates. The one thing to note here when you're getting up and running with Greengrass is that when you connect to AWS IoT, you'll see that we require you to have the root CA. The root CA it's a certificate that identifies AWS as an endpoint. And that's important so that you know and you trust that you're connecting to AWS. Well, when you're working with Greengrass, you're connecting to your own device. And so the root CA will not work. You cannot use our root CA to identify your device. And so that's one of the process changes, is that when you want to connect to your core, you need to use the CLI to actually fetch the certificate for your core so that your client can actually connect to the core. Outside of that single change, your device, as long as it has valid certificates, will be able to connect to your Greengrass core. Along with this, we of course support self-signed certificates, very much the same process that you would follow if you were using something like just-in-time registration. Along with this, the core also has a role, so the core can assume permissions and pass permissions to Lambda functions to access other services like DynamoDB or potentially write data directly to something like S3. I want to walk through a quick example here of the way you need to think about how data moves within the Greengrass core. So if we take the first line of this and I am publishing data, I will connect to the local Greengrass core and my certificate is verified locally. I will then publish to a topic, and then my subscription list, which I call a route table, is the easiest way to think about it, will look and match source to target and the topic. Everything is rejected by default. If there's a match, it will send the message on to the particular subscriber. That could be the cloud, that could be another device, or it could wake up a Lambda function. And then the same is true then for the next line, which is my subscriber. Everything follows the same pattern. The subscriber connects, the certificate is verified locally, it subscribes to topics, and then if there's a match in a route table to send a message to that subscriber, the subscriber will then receive the message. And then we have Lambda doing the same thing. Lambda sitting waiting for messages where it can do compute operations and publish data back out. Again, it gets woken up when there's a route sending data to it. And when it wants to respond, it needs an outgoing route to say the same thing, that it can send data to the cloud or it can send data to a local device. And keep in mind that modifying the subscription list is very easy. You can do it through the CLI, you can do it through the console, you can do it through the API, and then you just deploy those changes directly to your Greengrass cores. Let's have a look at a couple more detailed requirements. If you are trying to get Greengrass running on something that isn't listed on our website, so right now you could take a Raspberry image and you could put Greengrass on that device. It's tested. We know it's going to run really well. If you want to put it on your own environment, it needs to support Linux kernel. We have here 4.4, right? We test against 4.4. What we're really looking for is Overlay FS with C group support. Overlay FS was introduced in kernel 3.18 and higher. So anything older than that, it is just not possible. Anything newer than that, then there is an option with some work for you to actually get Greengrass running on top of your Linux kernel. And of course, that assumes you meet the hardware requirements, which is x86, and we have two types of ARM. So we have actually ARM v7 and ARM v8 available. v7 is for the Raspberry Pi 3. Any earlier versions of that device will give you an ELF error. So if you ever do see an ELF error, you do not have the right kind of hardware. Here's a short use case on a customer that actually implemented Greengrass. And so in this gas turbine environment, they have a lot of sensors. There's a lot of data that's actually generated on this device. In this use case, they wanted to look at the oil filters for this actual turbine. And so they were able to install a Greengrass core on a small device. They were able to get data from the sensors and have some basic machine learning models on that actual device that was able to predict and when the devices, so when the filters needed to be replaced. And they would actually just take a subset of data, and once an hour they were actually able to send that data back up to AWS. And so again, it was a small device. If you look at the diagram there, we have the turbine, we have the different sensors acting as devices talking to the core. The core itself consists of lambdas. The lambdas were aggregating the data, making decisions on when to alert an operator that the filters need to be changed. We had the shadow to actually look at some basic state about the turbine. And then we had our routing table rules. We have a couple FAQs as well. The first one is, what about shadow sizes? Well, because the shadows can be synchronized to the cloud, we still have the same shadow size limit, which is technically a 4K of reported state, or an 8K total when you look at reported and desired state. The next question is, can Greengrass cores communicate with each other? No, not natively. If you actually step back and think about that environment, there really isn't a need for cores themselves to communicate. There's nothing really for them to share with each other. But you can have devices set up in Greengrass groups that could communicate with each other and essentially proxy and relay information between two different environments. The next is, can we use wildcards in a routing table? No. We require explicit rules to be defined for all source and targets within the Greengrass core. The next is, can we subscribe to cloud topics? Absolutely. This is as easy as defining your source as the cloud and a particular topic, and any data on that topic will then be routed to the target that you specify. And then lastly, can you compile Greengrass to other architectures? So Greengrass is supplied as a binary, so that's not something that you could do. But if you have a project and you need help with different hardware, just please reach out for that request to your accounting or your partner team for support. Lastly is pricing. You only pay for active cores, and cores can actually operate offline for up to 5 years. Outside of that, an active core in a month is counted as active, and it costs 16 cents for a core, but there are no message costs. So you could have hundreds of devices communicating with each other, sending as much data as you want. At the edge, you are only paying for your 16-cent core. The only time you incur additional AWS costs is, of course, when you send data to the cloud. So if you're sending it up over AWS IoT, you'll have your per message cost as usual. Outside of that, you just have the 16-cent cost. All right, so next up, we're going to take a look at the demo. Before I change screens to that, I want to talk quickly through this architecture. So this comes from a real project and was showing how we can build some really cost-effective devices to collect data in kind of remote environments. So farming environments, maybe around lakes and dams, and oil and gas was one that this kind of originated from. And for this demo, what we had on the left side of this diagram is we had small microcontrollers. These are little MicroPython framework boards that use LoRa, and we're using point-to-point LoRa to collect data from a set of sensors. We then transmit the data over to a gateway device that was coupled with Greengrass. And so in this diagram, if you look at our gateway, that is running AWS Greengrass on a Raspberry Pi. If you look down in the picture on the bottom left, you will see I have a Raspberry Pi with a sense hat, is the right-hand picture. On the left is the actual transmission board. And once Greengrass gets the data, it can collect it, it can aggregate it the way I want it to be aggregated, and then it uses MQTT to get that data up to AWS, where we have a set of Lambda functions that store it in DynamoDB, make it available to Alexa, so I can actually have a skill and I can ask Alexa at any time, Alexa, what is the state of this particular oil site that I'm busy working with? And then after that, we push our data as well to a small dashboard. So for this demo, I'm going to quickly walk you through what this Greengrass group actually looks like, so that you can get a feel for the different components of a Greengrass group. And then we'll look at some of the traffic as it's streaming from the actual devices. Okay, so here we have the AWS IoT Dashboard. Here I can see some basic information about my connections, the types of data that are coming in and out, how many messages I'm publishing. And so I'm going to go in quickly and show you what a Greengrass group looks like. So for this is something called my Smart City Greengrass group that actually is collecting some of this data. Inside of my group, I can see the lists that we spoke about earlier. I've got my cores, I've got my devices, I have got my Lambdas, I've got all the different settings. And so you'll see here the different roles that my core can assume. I have control over how often the core rotates its certificates. And then I have the different login information. Here we can see that I have my one core for this particular group. I also have a set of devices. So if we look back to that earlier diagram, you would be able to see one of the PyCom devices that I actually have. And I then have my Lambda functions. And so these are what have been deployed to the Greengrass core and will actually be executing. And then the routing table, which we call a subscription list. And so here you can see source, target, and topic. Very simple. And I can see that when data comes in from a device here as a source, that I wanted to invoke this Lambda function. And I get to control the version, which is very interesting because it means certain devices can actually use different versions of the same Lambda function. And then I want it on this particular topic. And so when that happens, this Lambda function will wake up. And then when this Lambda function is finished, right, it's the same Lambda function, its target will now be the cloud. And so it's taking data that was processed at the edge, and it is pushing it up to another topic for me to then process on the cloud side. So to actually see this in action, I don't have a way to show you the physical devices, but I can show you what the data looks like. So this is, if you have not seen this before, this is our MQTT test client that is available in the browser. I can subscribe to Hash, which lets me see all the data flowing through the system. And so we will keep that up and running. And then over here on this dashboard, this is something I've built that actually shows the data coming off these devices. So again, these devices can be out in the field. They're really cheap devices, under $20, but they can transmit up to 21 kilometers, clear line of sight. And so it's a great use case, again, for something like farming or oil and gas or mining, where I want a way to move data around quite easily and then get it up to the cloud. And so I'm going to go ahead on my side, and I'm going to turn on the main gateway device. And so as that's starting up, it's going to connect to IoT, and it should publish an awake message. And we'll see that pop up here in the console so that we know that device is actually online. And you'll notice that we get two sets of data. So you saw how fast that actually happened. That was a message arriving and being repeated by the Greengrass Core almost instantaneously. So that message has gone all the way up to the cloud, back down through the core, and processed for us to then look at. So next, I will turn on one of the remote devices that is transmitting data. Now, again, this data is going to arrive at my Greengrass Core running on a Raspberry Pi, and then processed and then sent up to AWS on behalf of the transmitting device. So we'll give that just a second, and we should see data showing up here. And as that data is processing in there, we'll see it here as well in real time, actually coming up on the dashboard. And so on the bottom right-hand side, you can actually see a sample of the data, the raw sort of data that is coming in from the devices. Here, I'm just going to turn on one for this demo. We'll just look at one of these sites. But that is my 3 simulated chemical bins that are transmitting data. And again, if we think back to that earlier diagram, that data has been transmitted from a remote sensor over LoRa to a Greengrass Core. From the Greengrass Core is processed and sent up to AWS. And we can actually pause this for a second, and we can take a look at this data that's coming in. And you'll notice that I've got 2 different styles of data. I've got what is a very raw type of data, and then I've got something that is a little more user-friendly. And that is the difference between the raw data coming in and then being massaged by Lambda functions. So the Lambda functions are making the data more suitable for the dashboard that is actually consuming it. And so you can see that it's very fast. Okay, so in terms of demos now, that's probably the easiest thing that we can actually show you. You'll see that these chemical bins here will slowly run out. And when they do finally run out of chemicals, the status actually changes to chem low. That whole decision is actually made within Lambda functions. And so, we have rules going to Lambda functions that are looking at this raw data. Let's actually resume that. And you'll see our V1 values are now getting lower and lower. And so as soon as the Lambda functions see that, they can actually start processing data and respond to the dashboard that we've run out of chemicals. And then they can send a message back to the device. So on my side, the device is actually coming up now with a red light warning that the chemicals are running out. And then in a second here, we should see our status actually switching to low chem. And so that device now is basically out of chemicals, and we can, for this actual customer, we were able to, allow them to get this project up and running to help them with fulfillment. So, obviously chemicals don't run out this fast in the real world, but they were able to, send fulfillment trucks out before chemicals got this low. So let me stop that for a second. Okay. So that is it in terms of demos and in terms of Greengrass. If you would like to try Greengrass yourself, I recommend going into AWS accounts. If you come over to Greengrass, it is very easy to get up and running. The wizard will walk you through creating your first Greengrass group. It will create a core for you with the required certificates. And if you want to do it on an actual physical device, I recommend getting a Raspberry Pi. We've got some great instructions on the website for getting that up and running. If you do want to run it in the cloud, you can also run it on an EC2 instance. And then all the software is available here as well. So if you're looking for Greengrass, it is here within your accounts, within AWS IoT. You can come and actually get the Greengrass Core software. You can get the different SDKs I spoke about earlier, the main SDK, the Greengrass Aware SDK, and the regular embedded SDK. And when you configure your download for the core as well, just make a note of what hardware you're working with. So again, on V7 and V8 x86, you can download your Greengrass core from this. If you do not see Greengrass here in the console, pay attention to your region. You have to be in a region that supports Greengrass, otherwise you will not see that. So that is all I have. Thank you very much.